All right. Part 2 here, Pythagorean identities. These are quite arguably the most important of all the identities we're going to be doing. And given the name, what theorem do you suppose they come from?
No.
Pythagorean. What's a Pythagorean theorem?
A squared plus b squared plus c squared.
A squared plus b squared equals c squared. Good old geometry coming back here. So if I have my unit circle here, we've got a point on it, x, y. We can draw that triangle. What's the radius of a triangle on the unit circle?
1.
Radius is 1, side lengths x and y. Now what happens if I plug that into the Pythagorean theorem? A squared plus b squared equals c squared. 2 legs and the hypotenuse. Not necessarily.
Oh, the longer side that's not c.
Right. So 2 legs, x and y. So x squared plus y squared is equal to the hypotenuse squared, and my hypotenuse is 1. So 1 squared, just 1. Now here's where the magic comes in. What did we just say x was equal to? Which trig ratio? Proud? Cosine. X is cosine. So instead of writing x, I'm going to substitute.
Oh my God.
Cosine squared. And instead of writing y, substitute sine. Sine squared of my angle. And 1 squared is still just 1. Cosine squared plus sine squared equals 1. Main, most important Pythagorean identity. Quick word on notation, this is kind of extra for free. It's just the way we write this. Notice how I put the squared sign up here by the trig value. If we were to write it how you might have expected and write cosine theta squared, if you write it like that, it means take the cosine of the angle times itself, and only the angle gets squared. Instead, we want to square the whole side length, the whole cosine value. So when we write it like this, cosine squared of the angle, that means we're saying cosine of theta times itself again, cosine of theta.
Okay. Just right there.
You don't have to, just be aware of the difference in the notation. There means 2 different things. Now, sine squared plus cosine squared equals 1. That's one of the most important identities out there. There are 2 other versions of this Pythagorean identity. So I want you guys to watch what happens if I go through and divide everything in this equation by cosine squared. So I start with my original, cosine squared of theta plus sine squared of theta equals 1, and I'm going to divide everything in that by cosine squared. Divided by cosine squared, divide this part by cosine squared, divide the 1 by cosine squared. Now what can we do with that? Cosine over cosine is 1. What did we just say about sine divided by cosine?
That's tangent. Yeah, it's tangent.
That is tangent. So sine over cosine is tangent. Sine squared over cosine squared is tangent squared.
1 plus 2.
And 1 over cosine, what's the reciprocal of cosine? Secant. So 1 over cosine squared becomes secant squared. And that's version 2. 1 plus tangent squared equals secant squared.
This is big brain, fake brain. Wait, so numbers with is
Lost?
divide by
Almost left.
What would you guess we do to find version 3?
divide by sine.
Divide everything instead of by cosine. Gonna start with version 1, cosine squared plus sine squared equals 1. Divide all of that now by sine. Divided by sine squared, divided by sine squared, divided by sine squared. And what did we just say about cosine over sine? What identity is that?
Cosine over sine is tangent.
What?
Not tangent.
It's cotangent.
Cotangent.
Whatever.
So cosine over sine,
Okay,
cotangent.
this makes more sense though.
Sine squared divided by sine squared, a number divided by itself, is just 1. And the reciprocal of sine, cosecant. The reciprocal of sine squared is cosecant squared. And there's your third version. Cotangent squared plus 1 equals cosecant squared. So how do we use this? We're given that sine of t equals 0.28. T is in quadrant 2. We'll come back to why that matters, but we're being asked to find cosine of t. So we need an identity that connects sine and cosine.
Which is the first one?
It's the first one. Cosine squared plus sine squared equals 1. So cosine squared plus sine squared equals 1. And now we're being asked to find cosine. So before I go plugging in numbers, I'm going to get the cosine by itself, subtract a sine squared from both sides. That cancels out. So we end up with cosine squared of theta is equal to 1 minus sine squared of theta.
Oh, wait, this one.
Okay?
So,
Now let's plug some stuff in. 1 minus, we're given sine. Sine is 0.28.
0.28 and then you have to put
0.28, and we have to square it. So 1 minus 0.28 squared is 0.9216.
So I'm gonna
Are we done?
no.
What have we found here?
The square root.
Cosine squared,
So you just do your square root.
square root it. So cosine squared is 0.9216, then regular cosine, square root it. 0.9216,
Equals 0.9.
0.96. And anytime you take a square root, what do you need?
Plus or minus.
Plus or minus. So cosine squared is plus or minus 0.96.
So we're halfway done. Sort of.
Almost.
Almost halfway done.
Here's where we come back to the fact that it's in quadrant 2. Cosine corresponds to x, right? In quadrant 2, is x positive or negative?
Negative.
Negative. So within this plus or
It's
minus,
gonna be negative.
it's going to be the negative option.
So,
So we just write down negative 0.96 as the answer.
answer to cosine or answer to sine?
Answer to cosine. Cosine is equal to 0.96
Why do we do negative?
because we're told that the angle is in quadrant 2.
Oh, so it has to be positive.
Cosine, remember, is the x
Or
values.
negative, yeah.
And in quadrant 2, all my x values are
Negative.
negative.
Okay. So, but if it was sine,
Then it would have
it
been
would be
positive.
positive.
Yep,
Okay.
because sine is positive in quadrant 2.
Okay.
Yep, exactly. Now secant is pretty easy once we have cosine, because cosine and secant are reciprocals. So secant is equal to the reciprocal of cosine, which is 1 over that negative 0.96. And 1 divided by negative 0.96 is negative 1.042.
Wait, that's it? Oh,
And that's your answer.
that's it?
Yep.
I thought that was when we were.
The Pythagorean ones are a bit more work.
This is way better than
Reciprocals
everything else we've
are
done, Gina.
Oh, I'm glad. A lot of people find this challenging.
Don't say that, don't say that.
I mean, this is as bad as it gets.
Wait, are you serious?
Yeah. We've got one more problem
This
and
is way
that's
easier
it.
than everything.
Oh my god.
Okay. So let's do one more together here.
Who?
Tangent is 3 over 4. What is cotangent?
3 over 4, that's 1 over, oh, that's 3. Second?
So what's the connection between tangent, which we're given, and cotangent?
Oh, which is like the opposite.
So tangent and cotangent are reciprocals.
3, 4, 4.
So cotangent of z is the reciprocal of tangent.
Wait.
So if the tangent is 3 over 4, then the cotangent is 4 over 3.
Sounds real accurate.
So that's part 1. Now we know cotangent, and we're being asked to find cosecant. Which equation do we have that connects those? Version 3. Cosecant squared equals cotangent squared plus 1. So cosecant squared is equal to cotangent squared plus 1. And we know cotangent, so we can plug it in. That's 4 over 3 squared plus 1. When you're squaring a fraction, square the top, square the bottom.
Oh yeah, 16.
16 over 3 squared, which is 9. And we want a common denominator here, so instead of just writing 1, I'm going to write it as 9 over 9.
So 16 plus 9.
Now we can add across. 16 plus 9
25.
is 25 over the denominator of 9.
That's, oh no.
So that's cosecant squared.
Square root 3.
So we have to square root both.
Okay.
Regular cosecant
This is a quadrant 3.
is the square root of 25 over 9. Again, don't forget your plus or minus.
So it's gonna be negative, anyways.
Negative
5 over 3. And Connor says it's got to be negative. How did you know
It's a
that?
quadrant 3, and it's the bottom left, and both x and y are negative.
Quadrant 3, both x and y are negative. Bottom left. So cosecant corresponds with 1 over y. Y value is negative. Cosecant has to be negative.
Where did the 9 over 9 come from?
Is 1. Rewritten with a common denominator. So those are your answers. And we're going to skip that last box. Come back to it another time.
Thank God. Oh yeah, wait. So it's a homework.
Yep.